Working on quiz? Yeah? Not finished? Oh, so continue. So are you with me? Not finished? It should have been done, no? 11 minutes. It was 11 minutes. Took time. So now we are moving to binary arithmetic. By arithmetic today, we mean addition and subtraction. Just addition and subtraction. So we should think, we should learn how to add and how to subtract. To do that, again, we know that everything is similar. The only difference is base. So when the only difference is base, so we know how to do it in decimal. We know it from grade 2, yeah, or grade 1 in elementary school. From grade 2, we know how to add two numbers together. So it should be the same, but the base is different. So let's try. Let's see how could we do that. Okay. For base 10 decimal, everybody knows. For example, we want to add 531 plus let's say 729. How do we do that? We start one by one. We start from the right side, from the least significant digit, and go to the left. 1 plus 9 equals 10. So if it is 10, so we put 0 here, and then we have 1 here is a carry for the next digit. Then we have 1 plus 3 plus 2 is 6. We have 5 plus 7 is 12. So we have 2 here, and 1 is carried over. So here is nothing there, so it's there. So the result would be 1,260, the adding together. And if we are doing some kind of subtraction, again, for example, we are subtracting 891 minus 598. Again, when we are doing subtraction, I am teaching you grade 3. Yeah, is it grade 3? So 8 minus 1 minus 8, it is 8. We have to add 10 to that. So 11 minus 8 is 3, but we have borrowed 1 there, so we have to add 1 to this. So this one becomes 10. 9 becomes 10 plus 1. 9 minus 10, again we have to borrow 1 to it, so it is 19 minus 10. The result would be 9, but we have to add 1 to here, so this becomes 6. 8 minus 6 is 2. So the result would be 293. So this is something that all of you know. You know how to do that. Yes? So let's do the same thing for binary. The binary is also should be the same. Maybe the subtraction is a little more difficult than the addition, even especially when you have to borrow, like what I solved for you right now. So addition. Okay? So addition, the same thing. We write the numbers one by one and start from the rightmost digit, from the least significant bit. 1 plus 1 is 10 to binary. 1 plus 1 is 10, so you put 0 here and you bring the 1 carry over there. Then you have plus 1, plus 0, which is 1. Okay, so 1. Then we have 1 plus 0. 1 plus 0 is 1. 1. Then we have 1 plus 1. 1 plus 1 is 1, 0 in binary. 1 plus 1 in decimal is 2. In binary is 1, 0. So we put 0 here and we have carry plus 1 over next digit. We have 1 here, 0, 1. So 1 plus 0 plus 1 is 1, 0 again. So we put 0 here and we have 1 carried over there. We have 1 plus 1 here, so we have again 1, 0, 0 this, and 1 carried here, which will be here. So this is the result. 1, 0, 1, 1, 0, 1 plus 0, 1, 1, 0, 0, 1 is equal to 1, 0, 0, 0, 1, 1, 0. Okay? No problem? Everybody? Okay. So let's do subtraction. Now there might be a little trickier, more difficult. So we are subtracting 1, 0, 1, 1, 0, 1 minus 0, 0, 1, 1, 1, 0. How to do that? Exactly the same. So starting from the rightmost digit. 1 minus 0. 1 minus 0 is 1. So, okay, 1. That's good. 1. What happened? Erase. Okay. 1. 1 minus 0, 1. Then we have 0 minus 1, which we cannot do that. So we have to borrow 1 to that. So we borrow 1 to that. We give them plus 2. So this 0 becomes 10 plus 2 plus 10. 10 in binary, 2 in decimal. So 10 minus 1. 10 minus 1 is 1. 10 minus 1 is 1. But since we add plus 2 here, we have to add 1 to the next digit. Plus 1, 1 plus 1 is 2, 1, 0. And we have 1 minus 1, 0. Again, it is greater than that. So we have to give him a 1 plus 2, 1 plus 2 is 1, 1. So we have 1, 1 here, and here we have 1, 0. 1, 1 minus 1, 0 is 1. Okay, since we got plus 2 there, we have to add plus 1 here. Again, 1 plus 1 is 1, 0, and up we have 1. So we have to add 2 to that. We have to borrow this something. So 1, 1 minus 1, 1, 0 is 1 again. And then because we borrowed something, we have to add 1 to the next digit. 1 plus 0 is 1. Again, 0 minus 1, it is less than that. So we have to add plus 2 to that. So 1, 0 minus 1 is 1. And since we borrowed something, we have to add to this digit. Plus 1 plus 0 is 1. 1 minus 1 is 0. And that's it. 1 minus 1 is 0. So the result of subtraction of this number minus this is 0, 1, 1, 1, 1, 1. Okay. Let's continue. We want to make subtraction some kind of addition. What do we do in decimal? Let me go to the blackboard. What do we do in decimal? In decimal, when I want to, for example, do subtraction of 56 minus, let's say, 34, I can do the subtraction here. But what else I could do? I could make it minus 34. I could write 56 plus minus 34. I will change it to a negative number and add it to it. This is also the same thing. Is that right? Okay. But how it is different than this? If you want to calculate that, we have again to do the same thing. So, but we do something here. Sometimes what we do is instead of something that has negative number and we have to again subtract it, we add 100 to it, okay? 100 minus 34. So what I do is this, 56 plus minus 34. This is equal to 56 plus 100 minus 34, which I add 100 to this, minus 100. Because when you add something to an expression, you have to subtract it again. So they are the same thing. We add 100, we subtracted 100. So they are the same. But this thing happens here. Here, 100 minus 34 becomes a positive number. How much would it be? 100 minus 34 would be 66. 66. Now I can add 56 to 66, which I know addition. I wanted to get rid of subtraction. Now I did. I have addition here. 56 plus 66. I can calculate addition. 6 plus 6 is 12. 1 plus 6, 7 plus 5 is 122. And now, as you could see, it has 100 carried over there, which we have to subtract 100. We have 100 here, but this subtraction is easy. 122 minus 100, it means that you have to remove this. The result would be 22. So I wanted to subtract 56 minus 34. I used my addition brain. Let's say that my brain only adds. It cannot do subtraction. So I change the number to something that I add. Okay? Why did I tell you this? Because in binary, when we are going to design adder or subtractor, you see that this adder design is simple, is almost straightforward compared to a subtractor. So we are thinking of something that instead of subtraction, we do addition. And this is what we have done here. Let me show you one more thing. Here, I had to again calculate the subtraction. 66, so it's bad again. I wanted to get rid of subtraction, but again, I have 100 minus 34. Or if I could calculate the subtraction, I would do it at the first time. Why do I bother so many things to reach here? Here, I will tell you something. Look at 34. We can negate 34 to something which, how could I say? Okay, let me say this one. 100 minus 34. We wanted to calculate this. Again, it is a subtraction. How could we get rid of that? 100 is 99 plus 1. Okay? So I change this to this. 99 minus 34 plus 1. Are they the same? 100 is 91 plus 1. And look at this one. 99 minus 34. Since here we have 99, it means that for subtracting this, you just need to do it one digit by one digit. There would be no borrow, no going from this digit to because this is 9. Because this is 9, the result of this would be 9 minus 65. Yes? Whatever you write, for example, you write 7,926. If I want to negate it, I am subtracting 9,999 minus this. The result would be 3702. Yes? 9,999 minus this number would be 2,073. Do you agree? Okay. So we found a simple way to, let's say, negate this, complement this. This is some kind of complementing. 6 complements 3. 2, 7, 9, 0, 7, 2, 1, 8, and so on. Okay. Now that we have this one, 34 is 65. Now we can have, now we have addition. 100, so here, again, coming back to where we were here. 56 minus 34 becomes 56 plus 34, complementing 34 is 4 is 5, 3 is 6, plus 1 minus 100. Yes? Do you agree? So instead of subtracting 556 minus 34, we are writing this. And if you want, you can add this together, 66, 56 plus 66 minus 100. Okay, so I tried to show you this on decimal. Now we use this analogy and go to binary. That should help us. In decimal, we already know how to subtract, how to add, and how to borrow, how to have a carry on, and so on. But in binary, we want to design circuits. And designing a circuit for add, we can do. But how do we do for subtract? We can also do design for subtract. I am not saying that it is impossible. But why? When we have designed something for add, then we use it for subtraction. Why do we need to design another circuit, another component? We have other, we use it for subtraction. So let's see what could we do in binary. Again, what I told you in decimal, let me write for you. (52 minus 37). We have something else now. Okay, it's good. It is 52 plus 100 minus 37 minus 100, and again it is 52 plus 99 minus 37. Why 99? Because 91 minus anything would be complementing that. Plus 1, so it becomes 37, complementing 37 is 3, 6, 7, 2, 62. So it is 62, and then we add 52 plus 63. Okay? Okay, this is decimal. So now let's go to binary. And this 63, actually, this is the negative of 37. 63 minus 100. If you do 63 minus 100, you get minus 37. So we call this 63 negative as 37 without the sign. If you put a sign for that, that's the negative of 37. Okay. So that's what's that? Okay. We actually found a new way to negate 37. We complement it and then add 1 to it. So we go the same thing for binary now. Okay. Let's say we want to do this subtraction. 0, 0, 1, 1, 0, 1, 0, 0 minus 0, 0, 1, 0, 0, 1, 0, 0. To do that, if we want to use the same analogy that we had before, we add 1, 0, 0, 0, 0 to it and then subtract the same thing. The same thing that we had it here. We added 100 minus 100. Here we add 1, 0, 0, 0, and the number of zeros correspond to the number of digits that we want to subtract. Okay? So what happens here? If you do that, then you have this one is this one is this, plus instead of 100, instead of 1000, I write 11111 plus 1. It is like writing 199 plus 1. What we wrote here, 99 plus 1, we hear 11111 plus 1, the same thing. So if you have 11111 minus 00011, it is some kind of complementing. You see, we have 1111111 minus, let's say, 100100011. When you do, you have something. This is some kind of complementing. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 0 is 1. You see, each bit negates. 1 becomes 0. 1 becomes 0. 0 becomes 1. 0 becomes 1. 1 becomes 0. 0 becomes 1. 0 becomes 1. 1 becomes 0. So subtracting 1111111 minus anything would be complementing it bit by bit. 0 becomes 1. 1 becomes 0. Okay. So let's see what we are saying now. We are saying that you wanted to subtract these two numbers. What you do is that you complement this one by one. So 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 becomes 1. And then we have 1 here. We add 1 to that. So it becomes like that. And then you add these two things. Let me write it on the board for you so you could see what I mean. Let's write a number, whatever it is. 1, 1, 0, 0, 0, 1, 0, 0. Minus something. 0, 0, 1, 1, 1, 0, 0, 1. We want to subtract these two numbers. What we do, we are going to, instead of subtracting this, we are going to complement this one, and then plus 1, and then add these two together. So let's do that. This one becomes 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, and 0, 1. And then plus 1, because we had 1 there that we had to add. So this one becomes 1. And then we add this to this number, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0. Then we add these two together. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 0, 1 plus 0 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 0, 1 plus 1 plus 1 is 1 with a 1 over here. And then we told you that we have to subtract this with this number. It means that this removes. So this would be the result. Subtracting this number minus this would be this. 1, 0, 0. You could try it. You could subtract it directly as I've told you at the beginning, how to subtract these two. So the subtraction of this minus this would be this. Yes?
The first part.
Which one?
Like with the 1, 1, 0, 0, 0, when you minus it.
Here?
Yeah, like when you go to the, like from those two numbers at the top
To these two numbers.
Yeah.
Okay, this is the same, okay? This is the one. I didn't change it. 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1. But this one, we are complementing and then adding 1 to it. Why? I've told you, because we have a 1 here. We have 1 here. We complement this and then add 1 to it. I told you the reason. You're adding 1, 0, 0, 0, 0, 0 to that, and then at the end you subtract that. Adding 1, 0, 0 to that is adding 1, 1, 1, 1, 1, 1 plus 1 to that. And then 1, 1, 1, 1, 1, 1, 1 or something minus anything would be complementing that bit by bit. Okay?
But I'm wondering how the first one and the second one, when you minus it, you get the third one.
Third one.
No, like, could you explain
This one?
Yeah.
This one is the same as this one. We wanted to subtract these two. Okay? So this goes here without any change. This one, we complement it and then adding 1 to it. Complementing and adding 1 to it. So when you complement, means 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0, 1 becomes 0, 0 becomes 1, 0 becomes 1, 1 becomes 0. And then plus 1. And then you plus 1 here. Okay? Yeah? So this, again I say, this one is complementing this plus 1. Instead of subtracting these two, we add this plus this. So let me say, this we call it 2's complement of that. 2's complement of that. It is some kind of negative of that. Like this 34 that I told you, it is some kind of minus 34. This is some kind of minus that, but 2's complement. So you see how we reached that point. Instead of subtracting these two, we adding the number to its 2's complement. This is 2's complement. So 2's complement, how to calculate 2's complement? Complementing every bit and then adding 1 to it. Complementing, adding 1. Complementing is easy. 1 becomes 0, 0 becomes 1. And then adding 1. Yes?
What if when we complement it becomes 1 and then we need to add 1?
Yes, so it goes up. For example, let me put 0 here, okay? Then when you complement, it is 1, and then we add 1. So if you add 1 here, it becomes, let me do it here. It becomes 0, then 1 coming out. 1 plus 1 is 0, 1 plus 1 is 0, 1 plus 0 is 1, 0 is 0, 0, 1, 1. It becomes this. So this is the 2's complement of this. So whatever it is, you complement it and then adding 1 to that. Okay? And I told you how it did, from where it come. That we are adding something, subtracting something, and the things that I've showed you here in the slide. This representation for negative numbers is used in the 2's complement system. When we say that we are in the 2's complement system, it means that to negate something, to make it negative something, you 2's complement it. 2's complementing of something is actually negating that. So 2's complement. 2's complement is a number consisted of complementing and then adding 1 to that number. The same rule as sign and magnitude is used here. Do you remember what we talked about sign and magnitude before? When there is a 1 at the left-hand side, it is a negative number. When we have 0, then it is a positive number. You see, when, where is that? This one. When I added this to this, don't consider this. I got this number. No, which number? This here. This one was, I guess, this number. So this, no, I didn't get that. Where is that? 11 plus this one is become 11. Oh, okay. And the last digit is 0. Why did it? 0 plus, we tried something, it's, let's do it again. 0 becomes 1, and then we add something to that. Because of your question, I did something else. Let me erase this, and let me come back to 1. So this is 0, and then add 1, 1, 1. Okay, and then we 1 plus 0, 1, 1 plus 0, 1, 1, 1, 0, 1, 0, 0, 1, 1. And then there is nothing here. There is nothing here. There is 0 here. So it means that this number is positive. If you do something like that and then you get 1 here, then it means that the result was negative. Yes?
When you add 1 and 1, would you get,
Here.
would you get a 0 and then carry the 1?
So maybe I did a mistake. 0, 1, 1, 1, 1, 0, 1, 0, 0, 0, 0, 1, 1 is 0, and then 1. Yes. You mean that?
Yeah, and then the next one would be 0 again, and then carry the 1 again. Is that how that works?
1 plus 1 is 0, 1 plus 1 plus 1 is 1 with a 1 here.
Okay.
Yeah. Okay. Yes. But why it is 1 here? Okay, I will talk about carry later. So what does this 1 means? This 1 is the thing that we have added, 1, 0, 0, 0, 0, 0, that we have to subtract later, so we will remove it. Okay? In the two's complement system, the positive numbers have the same form as they have in the sign and magnitude, but the negative one, we will have to work on that. Two's complementing a negative number. Okay, two's complementing a negative number. It's the same. Let's say that we have a negative number. How do we have a negative number? We have 1 plus something here. Let's say we have minus 4. Minus 4. Okay, minus 4. No. How do I tell you? Okay, we have 4. What would be the two's complement of 4? This is 4. If you want, I put 0 here so we know that it goes. What is the two's complement of 4, which means minus 4? I told you, you have to complement and then add 1 to it. So adding 1 to it becomes 0, 1 plus 1, 0, 1 plus 1, 0, 1 plus 0, 1, 1, 1, 1, 1. Okay? So this is minus 4. 1, 1, 1, 1, 1, 0, 0. This is minus 4. So if you want to make it minus again, minus 4 is 4, you could do the same thing. Complement everything plus 1. There is a simpler way for doing two's complementing negative numbers when there is 1 here. How do you do that? You start from the rightmost digit number until the first one, and then complementing the rest. Okay, what do? We start from here. This is 0. Okay, 0. This is 0. Okay, 0. This is 1. This is the first one. So we keep it. From now on, we complement everything. 1 is 0. 1 is 0. 1 is 0. 1 is 0. So you see, we reach to 4. So 4. This is 4. This is 2's complement of 4, which means minus 4. To doing the 2's complement, you either complement every bit and then add 1, or it is easier. You start from the right until the first one, then negate all of them. Yes, please. Please louder. 1, 1. Okay. So what's the question?
Like with that, like if fourth complement, you're negating it and then adding 1. So like I'm just curious what you there at the bottom.
What we get if you do that? Complementing and adding 1, you mean?
Yeah.
Okay. So complementing this, 0 becomes 1.
No, like what you did for 4.
Here?
I just want to know if that's the
Do you want to come here, show me, or?
No.
Okay. Tell me how could I help you? Here, I didn't get the question. Please repeat again. Your question is how to make 2's complement.
The last digit, like if you complemented 4 that you did there at the bottom, wouldn't the last digit be 0? No, the side that, yeah.
It's one?
The side, like over here.
Here. Okay, 4. You mean 4. Okay, this is plus 4. Okay, this is plus 4. Then what I did, I 2's complemented it. It means minus 4. How did I do that? How did I do that? I negated, I complemented all the bits and then added 1 to it. 0 becomes 1. 0 becomes 1. 1 becomes 0. And then you add 1 to it. 1 plus 1 is 0 with a carry. 1 plus 1 is, let me write it here so you could understand. I wrote everything besides each other so you didn't get. So this is 4. This is 4. We want to find the 2's complement of 4, which will be minus 4. So we complement 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 becomes 1, 0 becomes 1. Then we add to 1. So we add to 1. One plus 1 is 0, and 1 is coming up. 1 plus 1 is 0, 1 is coming up. 1 plus 0 is 1. 1 plus anything, 1, 1. So this is minus 4. This is minus 4 in 2's complement system. This is the 2's complement of 4. If you 2's complement this, then you get 4 again. Let's try. For example, again, if I want to 2's complement this, first I have to complement. 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0, 1 becomes 0. And then I have to plus 1 to add 1 to it. 1 plus 1 is 0 with 1. 1 plus 1 is 0 with 1. 1 plus 0 is 1, 0, 0. You see? 4 again. 4 minus 4, 4. 2's complementing. Here I could say something which I have it in the last slide. You see, when we are talking about 2's complementing, that it means that we should have 1 bit for the sign. So if this is your number 00100, then you 2's complement, it becomes this. If you want to have, for example, 8-bit number representing -4, what would be the result? This is -4, but with 5 bits. If we want to represent it with using 8 bits, what would be the result? In 0? Okay. This was the one that I wanted to tell you. You have to sign extend it. Why? Let me show you. Isn't this 4? You said add 0. Okay, I add 0 here. 0, 0, 0, 0, 0, 0. This is 4. Do you agree? Do you agree? This is 4. Everybody agrees. Now we 2's complement this. 0 becomes 1, 0 becomes 1, 0, 1, 1, 1, 1, 1, 1, 1, 1. And then adding 1 to it to make it 2's complement. So 1 plus 1 is 0, 1 plus 1 is 0, 1 plus 0 is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So if it is 8-bit number, the -4 would be this. If it is 9-bit number, the -4 would be this. What does it mean? It means that you shouldn't extend it with 0. You should extend it with sign. Sign extending the number. If this is -4 in 5-bit, then this is -4 in 5-bit. Don't put 0. If you put 0, you ruined everything because it becomes positive. Negative number starts with 1. If you want to have -4 in 7 bits, this is the result. So you sign extend it, not 0 extend it. If it is a positive number, let's say, for example, 4. We have 4 like this. You want to make it 8 bits. So this is 8 bits. You want to make it 16 bits. 0, 0, 0, 0, 0. But this is -4. If you want to make it 16 bits, you have to sign extend it. Okay? Yes?
So, in short, if you want to extend a positive number, you add zeros. But if you want to extend a negative number, you add ones.
Yes, exactly. Sign extend. You remember this expression, sign extend it. Sign extend. Okay, now we know 2's complement, and for addition, it's obvious what we do. Nothing happens here, but for subtraction, we add it to the 2's complement of instead of subtracting, we add it to the 2's complement. I put examples for you, so I don't go through this, which become this one. Now, let's talk about overflow. Sometimes you say that, okay, I have 2 8-bit numbers. Let's say, for example, you have this number. Okay, this one is easy. You have 2 8-bit numbers, 0, 1, 2, 3, yeah, 8-bit number. You want to add these two. So the adding these two would become 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 with a 1 coming here, 1 plus 1 is 0 with a 1 coming here, and 1 is that. So if you are in 8-bit number and you are considering this as an unsigned number, so everything is good. You added 2 numbers, 2 positive numbers, and you get a positive numbers. But remember, this is an unsigned number. You shouldn't consider this as a signed number, because if you consider as a signed number, then it becomes negative, which is not correct. We added 2 positive number. If you make it decimal, I will show you. 4 plus 16, 20 plus 30. This is 52. and this is 1, 2, 4, 8 plus 32 is 40 plus 64. This is 104. So if you add 52 plus 104, you should get a positive number. The result would be 156. Okay? There is no overflow here, if you are considering this unsigned. But if this is a signed number, then we have overflow. Why? Because in 8-bit numbers, signed 8-bit numbers, 1 bit is for sign and the rest is for magnitude. What would be the biggest number, the biggest positive number with 8 bits? What would be the biggest positive number? 2 to the power 8 or 7, because one of them is the sign. So you have 7 bits. 2 to the 7, which is 128, minus 1 is 127. The biggest positive number with 8 bits, 8-bit signed number, is 100 plus 127. And what would be the biggest positive, the biggest negative number for that? It is hot, huh? Minus
negative 2 to the 6.
1, 2, negative what? Minus the number. What would be the least, the minimum number of?
Well, I don't know 2 to the 6 off the top of my head. 64?
60, no, it should be around 128, yes. So the range of an 8-bit signed number is from minus 128 plus 127. This is the range of 8-bit number. Okay? So if we are adding 52 plus 104, then in decimal it becomes 156, which is out of range. The biggest number is 127. So this will be acted as an overflow here if it is a signed number. You see? So if this is unsigned numbers, this is correct. You are adding this to this, which is corresponds to 52 plus 104, and the result would be 156, which is this. But if they are signed numbers, 8-bit signed numbers, then adding these two will make it 1 here, and 1 shows a negative number. So of course it is not correct because it is a negative number. So it means that you got overflow. You exceeded the range of the number, which is 127. The maximum number, positive number, is 127. A negative result has occurred from the addition of 2 positive numbers, if we are thinking as a signed number, not as an unsigned number. So the result could have been shown correctly in 9 bits. But if it was a 9-bit signed result, for example, we added a 0 here, a 0 here, then we get a 0 here, then that everything would be okay, because a 9-bit signed number goes from minus 256 to plus 255, and 156 is in the range. There is no overflow. So if we added 1 bit to that, so it becomes 9-bit signed number, so everything would be okay. But we were in 8-bit. In 8-bit, we got overflow. Here, there is an overflow. It means that your result has exceeded 127 here, and you should take care of that. Something is wrong if you are calculating in signed numbers. as I told you, you could sign extend it. If you can sign extend it to make it a longer number, so the overflow is gone. And for sign extending, if it is positive, you put 0. If it is negative, you put 1 at the left-hand side. Okay, so we have 5 minutes. Let me see. Oh, okay. We can have a question here. Let's see if I could do it. Where was the forum? I guess it was here. Okay, here. So I write question number 4. Question number 4, and I ask you to write your answer. Okay, ready? So click on question number 4 and are ready to reply to that. So the question is, for calculating 34 minus 59, write in form of adding 2 binary numbers. So, of course, it means that you 2's complement 559 and then add them together and get the result, and tell me what would be the result. So there are 2 numbers, 34, 59. You 2's complement 59 and then add it to 34. So write all of them to here. So in the forum, and then in binary, not in decimal. 34 binary, 59 first binary, then 2's complement, then add, then result. Okay, we have reply. No, not replied. What happened? Question number 4. What happened? 2. What happened? Competition. What happened to question number 4? Did you reply? Anybody? In here. Okay, 2 replies. We have 2 replies. Oh, you didn't write the whole thing. No, it is not accepted. Jonathan, Shota, please write everything. Mega wrote 2 things, but not the whole thing. Start from this minus this equals to this plus this, then the result, everything. Nasser also. So nobody have written yet. You have time. Write everything. Okay, Jeff wrote something. We will see that. No, not accepted. You have to write this minus this equals to this plus this and then get the result. I didn't look at Jeff's answer yet. don't like it. I don't like bright space. Okay, so I guess we can now look at the number. Jeff. We have Jeff, we have Nasser, we have Chris. So let's see if, no, E is not accepted. We have Mega, okay. We have, okay. So the first two, let's see which one is the first two correct answer. What was the question? What was the question? 34 minus 59. 34. 34 is 32 plus 2. 2, 4, 8, 6. Yeah, this is 34. This is correct. 34 minus what? Minus 59. 59 is 32, 16, 48, plus 8 is 56. This is 49. This is correct. Okay. So 2's complementing of this would becomes 0, 0, 1, 0, 0, 0 plus 1, which is this one. It's okay. So now you are adding, therefore the answer is, how did you calculate this? No. The answer is not it. This is the 2's complement of this, not the answer. Jeff, yeah, Jeff? Okay, no, this is not the answer. You were right up to 2's completion, 2's complementing. Yeah, it is correct. You add 1. So this is the 2's complement of this. This is correct. But now you have to add the 2's complement to the first one so to calculate the subtraction. Let's see what do we have here. Nasser, yeah? So minus 3, please, plus, I guess it is right. Give me 1 minute, don't go. Plus 1, 0, 0, 1, 1, 1. Okay, this is correct. Now you are adding that. When you add these two, look at here. When you add these two, it becomes 1, 0, 0, 1, 1, 1, which I think it's correct. And if you look at this number, this is a negative number. 1, 0, 0, 1, 1, 1. This is a negative number. Why? Because we were calculating, we were subtracting 34 minus 59. So it should be negative. And the result is this. So Nasser is correct. Chris, where is Chris? Okay, Chris, this plus this, exactly. So what is this? Oh, and then you calculate the, no, it doesn't. No, you didn't, you did something not necessary. We wanted to make it in 2's complement. So this is the result. This is the result, actually. And this is the real result. This is a negative number. If you 2's complement this, you could find out what would be the real number. Let me tell you. 34 minus 59. How much would it be? 59 minus 34 is 25. Minus 25. The result would be minus 25. Okay? Do you agree? 35 minus 59 is minus 25. Let's see. Nasser found something, huh? Minus 15, okay. Minus 15? 25. 25, yeah, 25, okay. So this is what found it. 1, 0, 0, 1, 1, 1. So let's 2's complement it. When you 2's complement it, it becomes here. It becomes something is wrong. No? Where is Nasir? Okay, here. We have to 2's complement this one. 1 becomes 0. Let me write it here. 1 becomes 0. One becomes 0, 0, 1 becomes 0, 1 becomes 0, 1 becomes 0 becomes 1, 1, no, 1, 1, 1, 0, 0, 1, 1, 0. Yes? This is This is complementing. We have to add 1. You see, this is the number that we have reached. I am 2's complementing it. So complement it. Please tell me if I did something right. So 0, 0, 0, 1, 1, 0. 0, 0, 0, 1, 1. Okay, it's okay. Plus 1. 1 plus 0, 1, 0, 0, 1, 1, 0. What's this number? Let's see. 16 plus 8 plus 1. How much? 25. So that was correct. We subtracted 34 minus 59. The result would be minus 25. And what is minus 25? This is minus 25. This is minus 25. You saw this is minus 25. When you 2's complement that, you get 25. Okay? So the Nasser was okay. And then Chris, no. He didn't write the 2's complement. Mega 2's complement is this. Mega is right. 1, 0, 0, 1, 1, 1. 1, 0, 0, 1, 1. So Nasser and Mega, where is Mega? Okay. Mega and Nasser. Where is E? E, okay. So you didn't write the 2's complement. You are right. You calculated right, but you just subtracted. We wanted to add it. Chris, E, Mega, Eric is the last one. Okay, thank you very much.
Is there a reason we didn't use the minus 100? No.
It was when I wanted to show you where do we reach this thinking, this kind. That was that. Now, no. There is, after you know the 2's complement, you don't do that. This is 2's complement. Everything is there. So if you add something, you get the correct result. If you subtract, you get the correct.
Do we have tutorial for today?
What?
Tutorial. We have tutorial today?
Yes.
At 4?
Do we have tutorial? Yes.
In the same...
We have tutorial today? Yes. If it is scheduled, yes. How many tutorial sessions? No, last week or last session. How many tutorials do we have?
Friday evenings.
And what is the other one?
There's no more. Just tutorial Friday.
for Friday.
No, there should be 2. There should be
Actually, there
2.
might be 2, 'cause you have
There
to
should be
do
2. I am wondering if the other one has already.
I think this week is the first week it's gonna happen.
I think so. Let me think. It is ITI tutorial. No, not today. No, the TA is not coming. I guess you didn't have it. You have 2 sessions. Let me see. We didn't have the other